Okay, well, moving right along, we're going to move into a smart and connected communities panel that's going to be moderated by Darby Watson. Darby's a strategic leader with experience in transportation and urban planning programs. She's a vice president at Parametrics with expertise in complete streets and urban design. Darby was the project development division director for the city of Seattle, responsible for defining objectives, constraints, and the risks for all types of transportation projects. She was also the Livable Street section leader for San Francisco's Municipal Transportation Council. Please join me in welcoming the committee and Darby.
Thank you so much. This panel, when I first started, and Jeff kind of told me to manage this panel, I thought about what is smart communities. This is a really kind of a vague term. And so doing a little bit of research and thinking through it, it's really kind of a combination of the Internet of Things, which is that relationship between different things and how they talk to each other that we're seeing pretty much something new every day, and the collection of data. And if anyone's worked in the public sector, you know that cities, agencies, communities are really kind of obese with data. And so thinking through smart communities is really about how we use those two things in relationship to manage our assets, manage our resources really efficiently so that people can live better. And my whole career has really been spent trying to make cities more livable. And so this really kind of meshed with my desire, my passion to make cities work better. And so we have a really esteemed panel for you here today. Let's go ahead and start with Steve Marshall, who is local. He is with the city of Bellevue, and he is the Transportation Technology Partnership Manager for City of Bellevue. Steve?
Well, thank you. The last panel was great. I don't know how we're going to compete with that, so we're not even going to try. We'll just do our own thing. 3 years ago, the city of Bellevue decided that they wanted to totally look new at what we were doing in Bellevue for Bellevue Smart. They wanted, and they put together a plan called Bellevue Smart to look at several different sectors of the city, water and power hookups and mobility and so forth. And that then led to part of that framework, which we adopted in 2017, to come up with more specific plans. And the part of the planning that I've been working on is the Smart Mobility Plan. So we created a Smart Mobility Plan last year, and we were trying to look, and I took a lot of cues from Doug, who I guess had to head back down to Portland, from what could we do in thinking anew with all the new technologies, all the new connectivity that we have. And we're basically now trying to figure out how to get ahead of the game. As many of you know from around here, we have Amazon coming in force. What Amazon was going to be doing in New York, they're apparently going to be doing here in Bellevue. And there's a lot of development of Amazon, maybe as many as 25,000 to 30,000 people in the next 4 or 5 years coming over to Bellevue. So we have a traffic issue right now. Traffic's gone from bad to worse to nearly intolerable. We're trying to figure out what are we going to do with the tidal wave of workers coming in. At the same time, we have companies like T-Mobile that are expanding. They've got their merger with Sprint, or excuse me, another couple of companies coming up. We've got Facebook coming in with lots of people. T-Mobile, of course, already has 7,000 people. So we're looking at almost doubling the number of people coming in and out of Bellevue every day. We've got a big Microsoft contingent. We've got contingents from REI, Facebook, and so forth. So on the one hand, it seems like a challenge in this framework that we're talking about here with the future of the profession. It's also interesting because the future of the profession seems to be to bring in all of these companies that have all of these ideas on what to do with the future. So our Smart Mobility Plan is trying to figure out how do we make Bellevue a nationally recognized leader, how do we improve safety with our Vision Zero project, how do we improve the efficiency of the networks. But to do that, the professions that we're organized with and partnering with are the ones that have the most information. We just happen to be lucky in our own backyard to have Amazon and Microsoft, the two largest providers of cloud services, to have Verizon and T-Mobile that are looking at the 5G networks, figuring out how to get that data up and how to do the edge computing that we have. We have companies like people may have never heard of, like NREX, that do the traffic data collection. We've got companies like Echodyne that do the forward-looking radar. We have Boeing in our backyard. We have PACCAR, who is making autonomous trucking and the kind of platooning, the virtual trains of trucks that are going to be going across the country. So in a way, the future of the profession is not that we're going to be losing people. It's going to be that we're changing from the kind of things that we were doing in the past to whole new ways of thinking, whole new types of things. And what we've decided to do is just to take advantage of that expertise that's in our backyard. So we've been working very closely with T-Mobile and Verizon on 5G, the city in general, trying to figure out how do we get ahead of the game, even though there's concern about how are you going to pay for this and who's going to do what. We already have a pretty good platform in Bellevue. We have a lot of fiber already. I mean, we have an enormous amount of fiber. We have our whole traffic signal system is adaptive traffic signaling. We have cameras everywhere. We've developed a way of looking at video analytics to look at near misses with accidents. So we were already kind of a cut above in terms of that. But what we found is that out there in the professions, out there in the real world, are people that are even farther ahead, much farther ahead than we would have thought. And this has happened in a relatively short time. It's amazing that we've gotten now to, this is Mary Barra, the CEO of General Motors, and their vision is a world with zero crashes. We have vision zero emissions. We have very strong possibilities about getting to that here in Washington State because we have a clean grid, a pretty clean grid right now, and zero congestion, which will be a tough one. And it's interesting to see what she thinks the future of mobility will be. It'll be the convergence of electrification, autonomous vehicles, connectivity, and shared mobility services, something that Doug talked about and trying to do integrated mobility services. And I know Metro and the state are looking at this too. But I was at a roundtable discussion with Metro, King County Metro, Sound Transit, and the State Department of Transportation last Tuesday. And it was moderated by a UK consultant to try to take a look at where are we going and what are we doing. And there was a lot of pessimism about, well, there's some issues, 976 and some other things that we have to deal with. But I said, 10 years ago, there were no electric cars that a normal person could buy. There were no Nissan Leafs 10 years ago. There were no Chevy Volts. You didn't even have the Tesla Model S. You had a Tesla Roadster, which was very expensive. And here we are, 10 years later. I open up the paper today, and Ford is making an all-electric Mustang, which nobody would have thought about 10 years ago. 11 years ago, people wouldn't have guessed that we would have smartphones, and they would be ubiquitous, and that we could connect everybody up with that. And of course, the Internet of Things just opens up all kinds of other possibilities. So the future of the profession, which I just read a book recently called Getting More from Less, or More from Less, about how we're dematerializing the world. GDP continues to go up, but our use of resources has flattened out. Hans Rosling wrote this book. And it's kind of an amazing thing to see the substitution for molecules of electrons. How are we getting away from gas and oil molecules to electrons to do things, to communicate, to move things, to analyze things with AI. It's really kind of astonishing in a 10-year period to see how much change there is. So the basic questions we have, here are some of the autonomous vehicles. This one on the left is the Chrysler Pacifica Waymo. This is a Jaguar entirely electric vehicle. We came up with some ideas for how do you take our existing van pool network and make it another van pool 4.0 with being electric and at least in part autonomous. And we've been open-minded about trying to think through how would this new world look with all the new capabilities? How would we pull things together? And again, our challenge has been, how do we work closely with the people that have all this knowledge? And then how do we get this tested out? So this is an actual photograph down at LA Metro's fellow that heads up the Office of Extraordinary Innovation, Joshua Shank. So he's been frustrated, I think, that things haven't moved as fast. But if you look back 10 years, things really have moved fast. And what we're trying to do is figure out, how do we bring more people into these conversations? How do we make things happen in a pilot-type program with demonstrations? How do we do a lot of the things that Doug talked about earlier today? So with that, I'm going to sit down.
Thank you, Steve. And I'd like to introduce Brian Nace, who is the Chief Technology Officer for GHZ Communications and specializes in 5G, which, if you don't know, you're about to learn how that is really going to transform what we do with technology in particular.
Morning. Let me see if I can do this. There you go. When we started out today and Jeff gave his introduction, this is kind of off the cuff, so bear with me here. He was talking about the different parts of the industrialization. In 1970 was the start of the connected times. And I thought, when I heard that, I thought, you know, that time I was a junior in college, my undergraduate, and the year before in my one physics class, we just had our first course in integrated circuits. So in my lifetime as a professional, I've gone the whole way through from cathode ray tubes, which were the standards, up to these systems that we're dealing with today. And I think in the future, it's going to be accelerating. So in those couple years in between 1970 and now, I've been blessed to do a lot of things. I worked the whole time in the private sector. I've done some work for DoD with radar systems, navigational systems, and flight control systems. I've done some things with on the private side. I think I have the world record of being the number of AVL installations. I say that every good engineer should at least do one AVL installation, but nobody should ever have to do two, and I've done 3 of them. So I've done that. In that process, I've gotten into network engineering, and in network engineering, my focus is on wireless. So I've taken the whole range of things from the start of what you call you'll see in a second, the 2.5G stuff, which was the first nationwide wireless network for a Ricochet network. I was a software development manager for the Network Operations Center for that. And then I got into this little thing called beamforming, which is one of the chief technologies for Wi-Fi, which allows the receiver to reach out further distances than its antenna. Instead of omnidirectional, it does a little math calculation. It says, well, I need to talk to you, so I need a little bit more energy in that direction. So I did that for Navini Networks, and I've done some feature testing for Cisco systems. I'm a Cisco engineer, and I have Cisco certifications. So that's where I am. Let me see. Now, the big question is, so what's this 5G stuff? Well, there's a story of the G's. So I just put together this little chart here, and I'm not trying to be real esoteric about it, but you know, you hear this 5G. What is 5G? Well, there's a timeline first of all, the term G is related to your cellular systems more than it's related to your Wi-Fi, although you'll see them talking about 5G wireless right now. So they're kind of mixing it up, but basically there's a series of functional features that you ought to expect to see for these different Gs. So we started getting into wireless communications very early in the communication timeline, starting in 1970, that magic time, and it started to be deployed in 1984. And basically this was analog cellular. These are your first cellular phones. We used to call them Motorola brick phones. You know, those were cellular phones. They were analog, no digital involved to it. Then next is 2G, and we get into some text messaging back and forth. And 3G is 1990, started to be deployed around 2002. And you can see that the number of features increases. And with 3G, we started getting internet access. Woohoo! Before 1996, there wasn't an internet. So all these problems we have with the internet didn't exist in my time. So there you go. So 4G came up in 2000, started deploying in 2010. And you see this term LTE. That's long-term evolution. That's kind of the format that 4G uses. Remember that, because I'll get back to that in a second when we talk about 5G compatible phones. Just remember, LTE is 4G. And with that, we started getting the capability to do texting, internet access, and the big change was to be able to support video downloads. And the 4G was good enough to handle all that stuff, but they had to do a lot of caching. So you can do video, streaming video, but you'll get a lot of buffering going on to start. And once it figures out the buffering, then it runs fine. But you couldn't do things like voice communications because you didn't have enough. It wasn't stable enough, and it couldn't have this. It couldn't have the constant latency that you need to do voice communications with it. And then there's 5G. So 5G's been talked about since around 2010. And there you got a whole bunch of features that are out there. You got the old stuff, that's SMS texting, the internet access, the video. And here we go. The Internet of Things, ultra high density, high definition, and 3D video streaming. So, and real-time applications. Now, you've never been able to do this with a wireless platform before because of that latency factor. If you look at that, I don't know does that have a pointer on it?
No.
If you look at the latency column, you'll see that up until the advent of 5G, the latency from one packet to the next is around 10 milliseconds. And one of the big targets for 5G is to get that down to 1 second. So within a second, that's almost wire speed. From network engineer, the difference between that and wire speed is this and this. And then the standard is a 5G evolution. It's not LTE anymore. It's 5G evolution. And the data bandwidth, you'll see that 4G typically is around 200 megabits per second in bandwidth. But if you have a fixed platform with a fixed antenna, you can get a megabit out of it if you're not sharing the resource with somebody else on your cell site. So we get into this term of typical throughput versus data bandwidth. And of all the things that I've struggled with over the years with a customer is, so why don't I get 54 megabits per second? You know, I'm putting out, you know, I'm using 802.11g. Why don't I get 54 megabits per second? That's because there's a difference between the bandwidth or the available capacity of the access point and what is actually deliverable. So what you can expect to see are throughputs around 20 to 40 megabits downlink and 2 to 4 megabits uplink for 4G. And notice it's asymmetric, so you get more speed down than you get uploads. And that's one of the key things about cellular connections is it's asymmetric. It's not equal in both directions. That's the difference between a wire and a wireless connection. Now the big jump, let's jump out here in the real world of 5G. 5G takes that number 20 to 40 and multiplies it by 10. That means that you as a user get more capacity download than you would get with a wired Cat 6 connection to your computer on your desktop. Download. And an upload, it's 20 to 40 megabits. You get better performance than you get with a wired connection on your desktop computer. And the other big deal is the cell capacity. Cell capacity for 4G is about 30 calls, 30 connections per sector of an antenna. So if you go to a cell site, you'll see that there's these big squares on the thing. Those are called sector antennas. And so each one of those can handle about 30 simultaneous calls. And now, if you look out at the cell capacity, and this is the big deal, is that goes up into the thousands per cell site, per sector. And they do this two ways, is they have increased improvements in the actual formatting and the processing power of the equipment. But they also use this thing that you're going to hear kicked around called small cells. Today, in the land of 4G, there's a cell site. You're familiar with them. They're cell towers. You look out and you say, well, there's a cell tower. And if you have a cell phone, you communicate to the cell tower, and then for that you go out the internet. That's the way of life. But with 5G, they want to get the capacity up. They want to get more users onto the network than that 4G antenna can handle. So the way they do that is they have these small cells. These small cells are about the size, I'll say a shoebox. They're more like a pizza box in size, about like so, and about this deep. And that thing works just like an access point if you're deploying wireless. The only difference is it's cellular capability. So if I wanted to support, if everybody in this room making a call at exactly the same time, I couldn't do it with 4G because somebody would time out, okay, off the same antenna. But what they would do is they would bring in a fiber connection, connect it up to a small cell, and we'd all be good. And they're doing this today. They're doing this today in the stadiums. And one of the biggest problems in stadiums is call capacity. You get 100,000 people in there, and they want to make a call, and you're busy out. So what they're doing is they're putting lots of small cells in the stadium. The other week I was at a football game, a college football game, and I just happened to turn around and look, and there's a small cell in the seat two rows up for me. So the advent of small cell technology increases the capacity of the network, the capacity of the ability to access the network. And then there's an interesting terminology here under the antenna technology. I don't know if you've ever heard of this MIMO. You ever heard of MIMO? Well, in the land of wireless, there's this ugly thing called multipath. So when I transmit from here, that signal goes out all over, and it bounces all over the room. And if you had this way of looking at the radiation, you'd see that it's interfering with each other. And so a lot of times you can get a high signal level, but no call completion because you get destructive interference. So what they have is MIMO, and MIMO is multiple input, multiple output. So in the past, cell sites, access points, had one antenna. You'll see them now coming out with 4 antennas, maybe 6 antennas. And the difference, what that means is that each of these antennas will be receiving whatever bounces off of whatever happens. I can't control it. It's just going to go out there. It's going to bounce off, and these 6 antennas or 4 antennas are going to receive it. And what it's going to do is the processor is going to say, here's an incoming packet. Can I reassemble all the mess that's out there well enough to get a packet back? So maybe 4 of the packets are just messed up 25%. But between the 4 of them with 4 antennas, I got enough to make a full packet. So that's MIMO, multiple input, multiple output. And the next one is multiple user, multiple input, multiple output. So that what that means, it's kind of the same thing. How many have ever heard of multicasting? Okay, well this is kind of sort of like multicasting, but it's with hardware, where you have one device that can listen to multiple devices at the same time and take action on it, or the converse is one device that can transmit to multiple devices. So multiple user, multiple access. So you have all these improved features. You have higher data bandwidth, you have higher user throughput, you have higher cell capacity, and you have this advanced antenna technology. Put this all together and you get something that's like 4G on steroids. Now, that's the good news. Now, the bad news is, in the US, you have to really be careful. I was looking around just to make sure I didn't say something wrong, but I was looking around at the different providers. There's very few true 5G devices out there. They're 5G compatible. There are 5G upgradable. There are 5G ready. But there's not many 5G devices. So the first question is that you need to think about is for your application, do you need 5G? Do you need that extra boost? If you need it, do you need it with 5G? For example, how many of you have an iPhone right now? Okay, that's LTE. Any of you go to football games? Soccer games? Stadium? Go to the stadium? Well, you're all working with small cells, but these are small cells which are LTE small cells. So it's a 5G technology deployed with the guts of 4G. Okay? And it works just the same way, but you're happy, they're happy, everything's good. So first of all, I would say look at your application. Do you really need capacity? Do you really need the all the features, or can you live with 4G? 4G is going to be around for a long time. You can't take a 4G equipment, you can't take LTE and turn it into 5G evolution. It doesn't exist, different hardware. And they're starting to roll this out around, it takes typically a 2-year rollout in a location, and you're not going to have the ubiquitous coverage that you would have right now with 4G. 4G, if you drive around the King County area, you'll be in 4G virtually everywhere. That won't be the case for 5G when it's first deployed. It'll take several years for that. I'm not sure exactly how 5G equipment is going to work in a 4G environment. I'm pretty sure it's not going to work, period, but I don't want to say it's not going to work. Their phone companies have work to do, and they're not going to, I just don't know how it's going to work. If you have something that you need a 5G, you think you need the 5G, most of the cell providers that are deploying 5G have lab environments. They have one, T-Mobile has one in the Bellevue area. I think we talked about that here. And so you can experiment with your application and make sure that your equipment is good for 5G. It's going to be great. It's going to change the complexity. It's going to change the landscape. You can see what the times 10s and the times 100s and so on. There's a lot of multipliers with 5G that you don't have with 4G. And 4G is good stuff. I still run my office off of 4G. So it's good stuff.
Brian.
Okay.
Thank you so much. And next we have Nico Larco, who is the Director of Urbanism Next at the University of Oregon in
Great.
Portland.
sec for my slides to come up. So my name is Nico Lark. I'm the professor of architecture, urban design at the University of Oregon, and I'm also the director of the Urbanism Next Center. And basically at Urbanism Next, we're looking at the impacts of new mobility, autonomous vehicles, and e-commerce on cities. We're less interested in the technologies themselves, although I'm here in a panel about technology. What we're really interested in is what are the impacts of those things on our cities generally. So thinking about things, the impacts on land use, on land values, street design, neighborhood design, equity concerns, environmental concerns, all these other pieces. Great, okay. So yeah, as I mentioned, we're interested in these things, and what we're really interested in, we learn a lot about, we spend much of our day learning about the technologies, those top 3 things, but what we're really interested in is how it affects the things down below, that affects cities. To give you a sense, which I think most people in the room, at least all those working on transportation, understand, it's just this world is changing extremely quickly. So last year, there were 4.2 billion transportation network company trips. This is Uber and Lyft type trips. In the country, 4.2 billion in a service that didn't exist 10 years ago. That's a pretty incredible growth. As was mentioned earlier as well, 38 million scooter rides, which started in April of last year, right? So just between April and end of the year, to give you a sense of how that compares, all bike share in the United States last year was 36 million after being here for 9 years, right? So in less than 1 year, we got to 38 million rides with scooters. And then level 4 automation, that's someone who's does not have to be in the front seat, is already happening right now in Chandler, Arizona, among other places with Waymo. And Waymo has put on order 82,000 vehicles. And as of 2-3 weeks ago, we were just in Detroit. Waymo has just started rolling out. They put a factory there rolling out these vehicles. This is coming, right? This is all happening. Change is happening now. We also look at e-commerce, which has just seen incredible growth. About 14% of retail right now is in e-commerce. Crazy statistic here, 16 billion e-commerce package deliveries in the United States. That's about 118 packages per household. That is 1 every 3 days on average for everyone in the country, every household in the country, right? Think about your logistics issues, right? This is enormous changes happening. So the moral of the story is change is happening now. The question we ask is, so what's this mean for cities? How does this change what's happening in cities? I'm going to run through one example of the tons of stuff that we look at, just to give you a sense of how that works. So one of the big ones we look at is parking. There's somewhere between 1 and 2 billion parking spots in the country right now, which is about 4 to 8 spots for every car. How many of you own a car? Right? What's your car doing right now? Parked. 95% of the time, it's parked, right? Anyone who does any work with transportation or development or design knows that parking governs a ton of stuff. All right, with this thing called TNCs, transportation network companies, with autonomous vehicles, and we think of TNCs as autonomous vehicles, but here today, right? Because same model, I call it up, it comes, I get in, it takes me somewhere, it goes and does something else, same thing. So we can look at these things and understand what the impact is going to be of autonomous vehicles. With these, we don't need parking anymore, or we need a lot less, somewhere between 80 to 90% reduction in the amount of parking that we need. So let's talk about the impacts of that. On the one hand, fantastic opportunities for density. All those empty parking lots, you can now put buildings in it. You put housing in it. And if I've got a housing development, I don't need to have enough space to put all the parking units in. I can actually use that space for a development, so I can increase density all over the place. Even in suburban areas. Office park, what for? What do I need all that parking for? Strip mall with a whole bunch of parking in front of it? I don't need all that parking. I can actually put development into those things. So huge opportunities for densification. Also great for the cost affordability of housing. Right now, on average in the country, 1 parking spot increases the rent overall for a unit about $225 per month. Right? It's a huge cost that we all pay if we know that we're paying it or not. If you don't need parking, it increases the affordability of housing. On the other hand, you have this thing called land that's available, that becomes available for parking. This is downtown Portland. This is more or less the amount of areas that there are for parking. Those are structures. In central cities, we don't have that much parking, the land that's used for parking. But as you move out to the suburbs, this is Gresham. There we go. Oops, sorry. How do I go back here? There we go. There. There's a ton of parking out there, right? So what happens when all this land becomes available in pretty short order? Huge opportunities for redevelopment. On the other hand, you're increasing the available land supply. Parking is the largest single land use in most urban areas, according to Donald Shoup, in any city, right? So what happens when you increase the land supply and keep demand the same? What happens when you increase the supply and keep demand the same? Prices drop, right? So we have a big question of what's going to happen with our land markets in these areas. And both those were important areas. This is in Cincinnati, which does not have, Cleveland, which does not have a tremendously high demand for development right now. Right? Look at all the parking that's in there. What happens when a place that's already weak in development demand, and you all of a sudden add all this land supply? So that's going to affect property values, which will affect property taxes, will affect all of our municipal budgets, right? So I show this as one example to put the point out there that AVs, mobility as a service, which was talked about a little bit before, are not transportation issues. These are everything issues. They're going to affect all parts of our lives. They're going to affect all parts of our cities. They're going to affect everything from how we get around to where we live to what our budgets are like. And same thing for e-commerce, right? The reason I say this is two reasons. One of them is I think it's true, and this is just one example I've given you. There's a ton that we can talk through. It's the work that we do all the time. Second reason is if we're going to make the changes that were talked about in the last panel, which was a great panel, if we're going to make those changes, we need to build coalition. We need to make sure that we're not just talking to transportation engineers, we're not talking to transportation planners, you're talking to housing advocates, you're talking to environmental advocates, equity advocates, economic development advocates, to make sure that you've got a whole coalition that we can actually make these changes happen. We've developed, in case you're interested, a framework to help think through all the different ways that these things are going to be impacting our cities, not just the transportation side, so land use, urban design, transportation, real estate, and how it affects things like equity, health, the environment, and the economy, and then what we can do about it. We put out a lot of work in these topics at Urbanism Next. We work across a lot of different sectors. And we invite you to take a look at that. Urbanismnext.com is the website. And I'll just put a plug in right now. We've got a conference that happens in Portland. This is going to be happening this year. It's in partnership with the American Planning Association, the Urban Land Institute, American Institute of Architects, American Society of Landscape Architects, and National League of Cities. So this is a place where everyone who's interested in these topics, not just transportation people, but obviously transportation people, can get together and talk about these issues. And actually, our call for proposals is closing in December 5th, so I invite you to come and submit to that, urbanismnext.com. And yeah, that,
Great, thank you,
I'll pass it
Nico.
on.
Wonderful. Well, let's start off with just a few questions. One of the things that comes up for me when we talk about these connections, kind of two things. One, the equity issue, and second, privacy and how that impacts all of our privacy. I mean, if we are walking around with our phone, we've essentially given up our privacy, right? Somebody somewhere is tracking us and knows where we are. Maybe they don't know who we are, but they are tracking us. So Steve, why don't we start with you in terms of privacy and equity?
Well, those are two big issues above my pay grade, and they really are policy issues. They're, how do you make sure that everybody benefits from these new technologies on the equity side? How do you give people access to jobs? There are a lot of people who live where they can't get to work easily, or where they have to take a lot of time to get to work. Maybe they have two jobs and they have daycare issues. How do you look at those kinds of issues on an equity side? And on the privacy side, we already give up a lot of privacy using our mobile phones. So the question is, how do you have an intelligent opt-in system so that if you want to connect up with Uber or Lyft or a Metro van pool and an easy mobility on demand type thing that we heard from Amy Ford and others, how do you make sure that they know where you are, because that's going to be part of the mobility on demand, and they know where you want to go, and then what do you do with all that data? We as a municipality, and the state does too, in Washington State have this very strict privacy thing where all the data that's available to a municipality is subject to a Public Disclosure Act. So people can ask for that. So are we going to be repositories of that? And I would suggest that people are trying to figure out ways of getting that data out, anonymizing that data to make the privacy stronger. But at the end of the day, it's that data and the connection and the instantaneous connection that's going to make a lot of what we're talking about work. So it's a dilemma. That's why I say it's above my pay grade. It's one of those things where you're going to have elected officials wrestling with this. And in a way we do. We created in Washington State an autonomous vehicle work group. The legislature did here about 1.5 years ago. We've been meeting. The very first report from the autonomous vehicle work group was put out a couple of days ago. It's available online. But more work will be done. It'll be over a 3-year period, and that's where a lot of these conversations will happen, and eventually it'll be a legislative decision, a decision by the different city councils.
Nico, you have some
I was
thoughts
just
on
going to add to that. So with privacy, I'd say on the one hand, we absolutely need to figure out a way of fixing it because Google and Apple know that we're here right now, right? That's no surprise, and somehow we're okay with that. So I think that at a federal level, we need to figure out. I'll say at the municipal level, we need to switch that to say that if data is allowed to be collected like this, and if, for instance, Apple and Google and Uber are allowed to have these things, why can't cities? Right? So I mean, we have this bizarre kind of, this is like a mental cultural shift that it's okay for Uber to have all this data about how transportation happens, but somehow the city of Seattle can't. Which I at least vote for the city of, well, I don't personally, but people vote for the city of Seattle and for the representation of the city in Seattle. Shouldn't that be a higher standard of like trust than Uber? And so in the city of Portland, we're doing this really interesting thing right now where they're purchasing replica data. So replica is Sidewalk Labs, Google, Sidewalk Labs, replica is an offshoot of that. And what they do is they create these enormous data sets based on cell phone usage, or cell phone kind of location, transactions, so credit card information, a whole bunch of different data sources, and they create a transportation-like model of simulated model of what your city is doing. And so Portland's the first city who's actually purchasing that data. We're actually validating the data right now to use that to make transportation decisions. And it's really controversial because this is data that's, in theory, so highly sensitive on the privacy side that no city should be able to use it, and yet it exists, and like Google's using it right now. But it's a really interesting model of how it is that you can use that to help figure out, plug it into your transportation models. And it's updated quarterly as opposed to the 2010 data that we're using right now in our transportation models. Like incredible opportunities there. So we need to, first of all, figure out the privacy side of it, and second of all, until we do, or after we do, let's at least let the public sector use that stuff as well.
Great. So one more piece on the equity question, and this goes to some of what Brian mentioned about 5G and that jump in availability. We still have places in this country where people barely have dial-up. What are some of the equity implications where cities like Dallas and New York and San Francisco are getting, this quality and this ability to interact at such a higher rate than some other parts of the country? What does that tell us? You want to start with you, Nico?
Oh, with me? So equity is a tremendous question across the board. On the one hand, there's the how quickly can I do it, but then there's a bunch of people who don't even have access to it. So we're actually doing a project right now with the Knight Foundation looking at autonomous vehicles, looking at 4 cities' pilot deployment of AV shuttles. And the big question is, how do we make sure that this is not just like for the wealthy or for a small segment? How do we make sure it's got a broader impact? And one of the first things that you run into is, well, there's people who don't have phones, and there's people who actually have phones but don't really know how to use them besides for texting and for email. And there's people who have phones but they really don't have data plans. And there's people who just aren't tech savvy, right? So I mean, there's this whole range of people who are outside of that whole piece of things. So I would bring it back to, I think that refers us to a question which is technology, but technology for what, right? So if we're talking about what we're really interested in is equity, no offense, but maybe 5G is not the thing that we need to be thinking about, right? If our goal is equity, maybe we need to figure out how it is that we get people who have limited means to have access to these technologies. So not to say that we shouldn't be doing these other technologies, but we need to figure out what our end goals are.
I would totally agree with you that, and my point is that whatever your application is, you may not need 5G, okay? And so the good news is that once you identify an area where you need to improve the availability, the access for the equality, using the small cell technology, you can quickly respond as opposed to the years that it takes to build a cell site. It might take a year to build a cell site and get all the approvals and everything. It might take you a couple months to put up a small cell. So there's technologically avenues to approach it, but I totally agree that the policy and the privacy are above my pay grade. I just build stuff.
I have a question for you, Steve, and I know you've been a big part of Bellevue kind of becoming a test bed for a lot of these technologies and piloting some of the new things right on the cutting edge. What do you do when things go wrong? How does that work?
Well, so far, I can't think of anything that's gone wrong in a way that, like a traffic signal malfunctioning and a crash occurring. Actually, it's been the other way. It's become a lot safer, and we just are rolling out a new Vision Zero plan. Our city council a few years ago said we want to do Vision Zero, which means no fatalities, serious injuries on roadways by 2030. So that means a lot. It means you've got to look at a whole series of things, which we've been doing, and we'll be rolling out a draft of that pretty soon. The state also has something called Target Zero, where it's doing the same thing. And one of the things we found out just recently is IIHS, the data collection for Insurance Institute on Highway Safety, has said that with just the new technologies in forward-looking automatic emergency braking with lane change departures, with backup, they're seeing dramatic reductions in crashes. 20%, I think Charles Knudsen of the governor's office said there's been a 56% drop in forward collisions. I don't know where he got that data, but all the data that's been out there from the Insurance Institute has said with these technologies, and you can buy them on a Kia right now today. I mean, it's not like you have to have a Mercedes. There are going to be significant reductions. You know, some people say 75% of all crashes are human error. Probably low. It's probably higher than that. And we've been looking at, through what I mentioned earlier, our video analytics at near misses as well, and going back and looking at other data that we have. We've got about 22 years of very granular, good data. And we're trying to apply that to looking at what the different suggestions are for crash avoidance. Would these work? Would eliminating left turns on flashing yellow do much? Would reducing the speeds? Would having more of these components in the cars, the automatic emergency braking, what would that do? And it turns out the state's doing some of that same kind of analysis, but it turns out that we're on a path to reduce the number of terrible accidents, and Charles Knudsen calls them family tragedies, by a lot. I mean, we probably won't get to zero in 10 years, but we're going to be making a pathway to get very close to avoiding the kinds of accidents that we all took for granted when cars were invented. You know, people just said, well, it's part of what you get. You know, you want to use a knife, you might cut yourself. You want to use a car, you might have a crash. So we've gone from crash worthiness, where we have seatbelts and airbags and crumple zones, to now crash avoidance. You know, how do you avoid the accident to begin with? And that has tremendous possibilities for everybody, and it is part of social equity. You know, if you're having to walk, or if you're having to ride a bike, or take other means, right now you're probably saying, I know, it may not be as safe as being in a car, so maybe I should get a car. Well, we can make that safer. We can make everything as low possibility of occurring as we can. So anyway, that's probably not the total answer to your question, but it's one.
So I was going to add, you asked, what happens when things go wrong? Mm-hmm. And I think kind of an important piece of the question is, things are going to go wrong. And if we're living in a world where things are changing tremendously quickly, and the status quo, staying the same, is a risk, that means we have to try new things, right? In the panel before us, you heard about all the changes that are happening. You're hearing about the changes that are happening. You're going to have to try new things. Well, if you're going to try new things, you're going to make mistakes at some point. So the big questions to me are figuring out what can go wrong, not what could go wrong. It's what is allowed to go wrong? What's okay to go wrong, right? We can't have a go wrong when a signal fails, right? And we have fatalities. but there's a whole lot of things that might be able to go wrong that maybe that system wasn't as efficient as we thought it was, right? Or maybe there's a lot of delay happening or some type of thing. But what's important is that, as definitely on the public sector side, is that you, and it was said in the last panel, instead of like eliminating risk, figure out how to manage risk and where it is that risk can be managed, and that's okay. And that is a huge step, like shift in the way a lot of public sector agencies work. The Office of Extraordinary Innovation, which was mentioned before in LA, has done a fantastic job to say, there's part of the agency that absolutely has to like perform and like be solid and deliver things, and then there's all this stuff that we got to try out and we might be able to fail at. And they've like partly, what they have is they've got political cover because the leadership has said like, we're going to try this, and then they do a fantastic job in messaging of like, we're trying things out. This is kind of this crazy thing. So there's an acceptance from the public side of some things might not work. In fact, they do some projects where they've got multiple approaches to the same thing. Some of those are not going to be as good as others. Obviously, we've got three solutions to the same problem. Some of those aren't going to work. And that shift in the political support, in the risk taking that the agency can take, and in the communication with the public to allow the agency to fail, right, is extremely important. I think as in a quickly shifting environment, we have to be able to do that.
Well, and I think what you're hitting on is developing a culture of innovation within agencies and cities, which anyone who's ever worked for agency or city knows that can be really difficult. Cities, having been in the public sector for a while, cities really get overwhelmed with how much data there is available and what you can get involved in. How do you make those choices? How do you sort through this kind of avalanche of information and use it to make decisions? We can easily get sucked into, let's go study that, or we have the ability to get information about something, so we run and do it. So how do you sort through that? How do you set the tone? I'll start with you, Steve.
Well, it's interesting. There was another conference yesterday, the Pacific Northwest Economic Region, PNWAR, and they described all the data that's coming now from the vehicles, and it's gone from very, very little to like terabytes of data every day, like 4 terabytes of data per car coming out. So what do you do with all this data? Well, one of the things the Autonomous Vehicle Safety Subcommittee has looked at the state level has been, how do you sort through this data in a meaningful way and then come up with suggestions on doing that? And how do you even get to the investigators of a crash, the state patrol or local officials, pertinent data? And one of the things we've been looking at is now with all that data, you've got, like in Teslas, you've got 8 cameras and sonar and the radar type things, and other cars other than Tesla, you have LiDAR. So you have an amazing amount. So let's say there's a collision at an intersection. One thing you can find out, did anybody put on their brakes before the collision? No. Was the light red for this particular driver or not? Well, you can know that right away. And you can know whether any of the systems have failed. You can even know if you have some GM cars, was the driver paying attention? Was the driver looking a different way, looking down at their cell phone? A lot of them are. I saw a couple of them today coming in. And it just makes you wonder. So with all that data, the real question is, well, what do you do with it? How do you could probably do this for fatalities and for serious injuries that you'd want to look into it. But how do you make use of the data? This is where artificial intelligence comes in, where you can sort out and look for exceptions, train the computers basically to figure out, well, what are the patterns? What are big patterns that you can look at? And that's again an amazing thing. That's what Amazon and Microsoft and some of these other companies that are in our backyards are looking to do. You've got the cloud capability to store the data. You've got the artificial intelligence programs that are being able to sort out and look at the patterns. And then it comes to the governance, the state, local, to figure out what do you do with that data once you get it. That's kind of just where we are. We're trying to figure out, well, how do you take that avalanche of data and make things safer, make things more equitable?
Great. Let's take some questions from our audience. Do we have that up? All right, if TNCs reduce the demand for parking, why is there a continuing insatiable demand for park and ride lot spaces serving mass transit? That is a great question. Want to start with Nico?
Yeah. So we are in this ugly in-between zone right now, where hats off to anyone who's willing to do development right now because things are shifting quickly. So on the one hand, we've got parking in some cities. Actually, parking. San Francisco saw a 12% reduction over 2 years in the number of cars that were parked in the municipal lots from 2016 to 2018. So some places are seeing reductions in parking, and they attribute a lot of that to actually TNCs. So that type of thing is happening. At the same time, and my sense is we're going to continue to see that. Partly, hopefully, in the Seattle area, you're seeing a lot of that based on transit use. People are reducing the amount of parking that they need. But we're at the beginning pieces of this, right? We've got some deployment, 4.2 billion trips in TNCs, but that's a drop in the bucket compared to what the total number of trips and the trips that could be happening. So the big question will be when Waymo decides, Seattle, here's your 4,000 AVs, right? And people start using that, and we start seeing substantial reductions in the use of your own private vehicle that you need to park. That's when you're going to be seeing a lot of those impacts. And that could happen in fairly short order, right? As soon as that service is available, think about how much growth we've seen in TNCs. The second part is, I love the idea that the problem with the parking is how I do the park and ride. That's great. If we can figure out first, last mile solutions to have transit be the backbone, which I'm a firm believer on, transit has to be the backbone for geometry reasons, right? But also for equity and sustainability reasons. Absolutely. So we are in this bizarre in-between moment right now where I'll tell you, we work with a lot of people who work in the transportation field that focus on parking, and their recommendation over and over again is don't build any parking you do not absolutely need, and if it's going to be structured, you better make sure that it's flat slab and high floor to floor so you can translate it into something else later on. Because on your 30-year bond that you've got to pay back that thing, I can guarantee, a few years ago I wouldn't guarantee, but I can almost guarantee now that in 30 years our parking utilization is going to be substantially reduced. And if you're assuming that that's going to be part of the revenue source, you will be lost. $2.8 billion in the U.S. goes to parking in the 25 largest cities. That shift is starting to happen and will continue to happen.
Great, thank you.
So I just
yeah.
add, Metro's already experimenting with a company called VIA, getting people down to the Rainier Valley transit. And I don't know all the details. There are people here in the room that know more detail, but it looks like it's a very successful way of trying to get people who, and there's no parking down the Rainier Valley, so that's not an issue. It's an issue of how do you get more people to transit to take them, and VIA's doing that. In the outlying areas, it's probably going to be a lot tougher to try to pick people up at their homes and take them to a park and ride so that they can take mass transit. There may be other ways that you can aggregate people and make use of more church parking lots and underutilized warehouse parking space. I don't know, but at least Metro's experimenting with trying to figure out, well, how can you link people to first mile, last mile solutions? And there may be shuttles that do the same kind of thing. We've looked into that, and the technology is not quite there to do what we're thinking about doing in Bellevue from the transit center to other places around the downtown area, and then back, of course, up a hill in the rain, in the dark. That's one of the things that kind of limits transit use, is that people need to feel safe. They need to feel like they don't have to walk in the rain or be out there in the dark. So, but all of these things are happening. I mean, all these solutions, all the technologies that are coming, and like Doug said on the first panel, we need to start looking at it and experimenting with it, and looking at frequency and reliability, and how do you get people where they want it? How do you look at the customer and build from the customer up?
The question is 5G required for automated vehicle use? And I would venture to say no, since they're operating now.
They're operating now. I think the big question is for the internal guts of the autonomous vehicle calculations, it's not probably required at all. for the V to X communications, it would be helpful to have a low latency type of communication, but you can do that low latency with a number of different sources other than cellular 5G. Could you do it with 5G? Sure. Now let's back up a step. If I were to want an autonomous vehicle that would be able to drive coast to coast, probably I'd want it to be 5G, because I'd want ubiquitous coverage coast to coast. But remember, that would mean that I'd have to have all the other vehicles also communicating on that. So it would be helpful in certain aspects, but it's not necessary.
We were just at Waymo in September, October of this year, talked to them about this very question, and they said, nope, no need, nice to have in some places, but not in the least the need. And there's two big reasons for that. First of all is if any AV company that's relying on 5G to be able to move is going to be able to cover like 0.01% of the roads in the country, and that is not a market. And so all of them, they will be working on the roads as they more or less exist right now, hopefully with slightly better paint, but the roads as they exist right now and without any new innovations in technology in terms of 5G. The second reason is that Waymo is extremely adamant about this, that all of the operation of the vehicle is completely controlled within the vehicle. In other words, they are not communicating with anything. The only thing that they're using is their own internal brain and what they can sense. And the reason for that, we talked about it a couple of years ago with them, and they reinforced it again when we were just there a couple months ago, is they are completely concerned about hacking. And when Waymo, which is Google's autonomous vehicle arm, says that they're concerned about hacking, we are all concerned about hacking, right? Like that. So if they say that we don't need 5G because they're not going to be talking to anyone about any information that's going to help affect the operation of the vehicle, there is no need for 5G. And I'll venture slightly out there, which is to say a lot of the discussion about 5G is often about, well, we need these instantaneous communications. I love the way the things that you're talking about, which is there might be other ways to do it that might be cheaper and faster that aren't these things which are tremendously expensive and slow to roll out. So it goes back to what are we trying to solve? What are we trying to get to? And then that's we should be optimizing for that question.
Yeah, don't forget that every vehicle that you put 5G in to do something like this also has to be covered by the service plan with the cellular provider. So I don't know if I like that idea either.
Great, let's go to the next question. Women in transportation. Women are likely to get injured and crash. Vehicles are designed for men. Women are harassed on the street. Impacts transit use. Are smart cities for all of us? How does that impact us? Well, as the only woman up on the stage, maybe I should answer that one.
Wait, too many men up here.
Sorry to point that out. I would, it's absolutely a thing, and I think it's the first step is recognition, and that it is an issue that women maybe respond differently in different situations. Their bodies are different. Cars are certainly not designed entirely for women, and certainly in my more recent experience for pregnant women, very challenging. So how, as we move these technologies forward, I would say the answer is to have more women up on this stage, making the decisions and in the industry. And we've been having lots of conversations about this at Parametrics, but we certainly did at the city too, in terms of inclusion and making sure that everybody has a chance and an opportunity. We have all voices at the table when we're discussing these things and making decisions and developing new technology.
And if I can add to it, one of the big questions, especially with autonomous vehicle, is there's no one in the car, right? And we know that if the system's going to work well, it's going to be shared rides more than individual rides, right? So more than people who don't know each other in the car at the same time. That is a really uncomfortable situation for a lot of people, but especially for women, depending on where you are and what time of day it is, and who just got into the car, and how do you solve for that? That is I think I would say potentially a deal breaker for a lot of these things. But we need to figure out, the fear is that, and I just read about someone who's starting to do some kind of like a system of trusted people, right? I can ride with other women, okay? I can ride with other people who are somehow, certified that they're kind of safe. And that really quickly becomes a Big Brother, Black Mirror kind of episode where only certain people ride with me. So we need to protect vulnerable populations, not only women, but vulnerable populations. And at the same time, we need to make sure that we don't create bizarre social structures that end up causing all sorts of other problems.
Mm-hmm. Yep, great. Interested in thoughts regarding reliance on these technologies and concerns about cyber attacks. You talked a little bit about that, Nico, but that is a risk. We've seen a lot of high-profile cases with hospitals being held by ransomware. We have cities with tons of legacy systems that are probably pretty prone and open to these types of attacks. So we'll start with Steve. What are your thoughts from the city side?
Well, if you're looking at vehicles and mobility and so forth, think about airplanes. I mean, if there were a big concern about cyber attacks and taking over airplanes, a lot of people wouldn't get on a plane right now. But they're all self-contained, as Nico was saying. Just like the cars that Waymo, Google is making, they're all self-contained. They don't reach out and they aren't subject to the hacking. It's the information that gets downloaded later on that could be hacked. It's the systems in cities. It's the communications, for example, with adaptive street light and intersection controls that could get hacked. But then you have to ask, well, where's the money in that? I mean, why would people, except for motivation of malice, want to do that? I think the ransomware thing is probably the biggest issue. But not so much with the mobility and not so much with these other things about the vehicles, including airplanes.
Great. Are there systems models that are converting parking lots into green infrastructure for climate change adaptation? That's a good question. Nico, you know of any?
So there's definitely parking. There's a lot of experimentation with shifting parking to other things. There's especially like a whole lot of things that just happened recently in Boston. Like 4 lots are working to be converted. A couple different models around the country. So if we talk about parking structures, it's complicated because these are typically ramps, right? Which is hard to like do anything on a slope, and they're low floor to floors because you want to reduce the price of construction. And so there's not a ton of those things. Places that are flat slab and still have low floor to floors, you can do housing, which can deal with kind of lower floor heights. Outside of that, it becomes really harder. And so one of the things that we talk about a lot with people is how can you have flexible parking, which means that you've got some parking that's going to be permanent, but some parking that can really be just erased, so surface lots are a big piece of that, or that are convertible. And you kind of have to need to think about, and it doesn't pencil out yet, but I think it will eventually, and potentially in the near term, that you can think about parking structures as you think about parking lots right now as land banking, right? I'm going to use this for this other use until I get to the real use. You can think of parking structures as building banking, right? I'm going to build a building that eventually is going to become this other thing, but I'm using it right now for parking because it needs to serve this other piece, which is there's costs associated with that, but eventually these costs are going to be outweigh the risk of not being able to pay for or having a building 10 years from now that has no real use to it. In terms of parking lots themselves, there's 2 things that I think are happening. One is as we need less parking or we can reduce the total amount of parking that we have, we're taking some of those things and redeveloping into other pieces or creating open space. The other thing is just creating, before I did all this work that I do right now, my background's all in sustainable urban design. And so thinking about sustainable systems within things like parking lots. So thinking about swales and planting trees, doing things that reduce the greenhouse gas, the urban heat island effects and things like that in the areas, and deal with stormwater. Absolutely possible and a good thing.
Great. I think overall the shift away from parking will give us more opportunities for those types of things.
It is a huge use.
Yeah.
I mean, like as you start looking, so one of the things we're doing right now actually with students is looking at not only the amount of parking that is in areas, but looking at what the typology of that parking is. Is it all in front of a store, right, which we can do something else with, or is it a thin strip around a building, which gets really hard to use? What are the different typologies, and what might you be able to do with those things?
Great.
It's interesting. I was at a conference at SeaTac that the Port of Seattle put on about 10 days ago, and they're seeing, because of TNCs, a drop in parking. I mean, if you can take an Uber or Lyft or whatever, be dropped off, you don't need to park your car there. So they're seeing less demand. And one of the things that they've been talking about doing, in fact, they had the second biggest parking structure in America, apparently, out of SeaTac. That's one of the facts that I heard. But they're thinking of taking the top floor of that, taking all the cars off, and looking at urban air mobility. The electric copters, I think Amy Ford talked about that at ITS in Singapore, which has opened up one of these electric and maybe eventually autonomous ways of getting people shorter distances, greener. Boeing's looking at it. A number of companies around here are actually looking into that. So that's why SeaTac put on this conference. But it was interesting to think that they could take that top floor and actually use something for a different kind of mobility.
That's a great lead into the next question about drones included in your research, and where's that sector going? I know a lot of companies are looking at this, so what do you think?
So I'll start with that. Get a lot of opinions about this. I'm not convinced yet, I'll tell you. We don't do a ton of work in drones, so you should take that with a grain of salt. But I think that there's really, and we think of drones in two sides, the aerial drones and terrestrial drones. Aerial drones, I think there's the two big barriers that exist are, one, they're really loud. Well, I'll say three barriers. One is that they're really loud, which I think will be a real nuisance for people, and no one really wants to accept that. No, I don't want it over my house all the time. Second part is I don't want it over my house all the time, right? Like the privacy issue of these things buzzing around. I think it's different when it's way up high. It's different when it's really down low. And the last one is safety issues. It's one thing, to me it makes total sense, like if you're in a more rural or more sparse setting, as soon as you're like in urban environments and there's like wires and trees and things, that is just a recipe for disaster of like that thing falling on someone. And so I find it really hard to work through those pieces and make that all work. Honestly, the privacy and the noise, I think, is the biggest issue. I think people just won't accept that. But we'll see. Terrestrial drones are, like, they exist right now, right? So these are the, like, we call them a cooler on wheels, right, that goes around and, like, delivers Chipotle and all sorts of things. Those exist. There's a ton of pilots happening in DC. I was in Berkeley a couple of weeks ago, and 3 of them on the same sidewalk moving together. A lot of college campuses. Bizarrely, they seem to be working. It seems like there's such an opportunity to like disrupt them, just like kick them or like put something in front of them. But the models seem to be happening. I'm not sure how much how cost effective they are, but they seem to be working in terms of people aren't bothering them. There's a big question though. I've got this photograph I just showed in a presentation I did last night here at ULI with 3 drones in the sidewalk at the same time. People taking pictures of them. What happens when there's like 40 of these things? Like, do they go on the sidewalk, or do they go with where the bikes go, or do they have their own lane? Do we want to prioritize those things? What happens if I'm in a wheelchair? What if I'm elderly and I see this thing and it's like completely disturbing me, and I'm worried about falling over the thing? So I think that like that's a big question of like how we start regulating that, what part of the city, what part of the street we want those things in. And I go back to, what is our end goal? What do we want to get to? Okay, goods delivery, is that an important piece of our entire portfolio of things we want to happen in society? Okay, what's the best way to do that? Is this one of those avenues?
How are successful cities, this will be our last question, how are successful cities addressing the influx of data they're seeing? We kind of already answered that. I think some of this maybe goes to how are cities prepared to deal with this data in terms of staffing and hiring, and how do they put together that innovations group or that group that oversees some of this work? And of course, that's part of your role there, Steve.
We've been looking at it because we already have a lot of data now, in large part because we've got cameras at most of the intersections in Bellevue. We get information. Most cars made since 1988 have OBDs, onboard diagnostic ports, and you can get a lot of data off of that already. Sometimes the police departments can go into court and they can get that data. It's a complicated process, but there's a huge amount of data that can be mined, and I think what we're seeing is these companies, tech companies, a lot of it is out of Microsoft and Amazon and some of the others around here, are looking at using, again, artificial intelligence to sort through patterns and all. It would be very difficult to hire enough people to look at all the data that is now out there. Even the ordinary data that's been collected over the years, how fast was somebody going, what skid marks were there, that's really been tough to try to organize in a systematic way. But if you do organize it in a systematic way, then you can get to better answers about what to do about it. What different kinds of options? Is it reducing speed or preventing right turns on red? Is it letting pedestrians go first in a crosswalk before the light turns green for the cars? There are a whole bunch of ideas out there, but you need the data to kind of back that up and say, okay, this one we ought to go for first because it can have the biggest impact at the lowest cost for the most people. But it's a challenge that these companies are now trying to figure out, well, how can we provide this data? I mean, Microsoft worked closely with the city of Bellevue on their video analytics. How do we take all this video and then make sense of all the images that we're seeing? How do we train the artificial intelligence to recognize a fire hydrant instead of a dog? All these things are being done not by the public sector, but they're being invented, and it's questioned as to how the public sector best uses that technology.
Yeah.
I think one of the bigger problems I would see, on top of what do you do with the data, is where do you store the data?
Yeah.
And when you're talking about terabytes per day, you can think about the size of the data center each city has to maintain. Not to mention the power consumption. That's a secondary problem to it. So I see more of this going to virtual data centers for storage because it's more efficient.
Mm-hmm. Yeah. Great. Well, Steve, Brian, Nico, thank you so much. I really appreciate you coming and talking about. Thank you so much.